This year's grand award winner is the Goethals Bridge Replacement Project. This $1.5 billion public-private partnership contract included the design, build, finance, and maintenance for the new bridge. The two long-span cable-stayed bridges provide three 12-foot wide lanes, a 12-foot wide outer shoulder, and a 5-foot wide inner shoulder in each direction, along with one 10-foot wide multi-use pathway. A central corridor between the roadway decks to accommodate potential future transit services was included in the design. The massive spans provides 138 feet vertical clearance supported by 33,000 cubic yards of foundation concrete, 27,000 cubic yards of concrete in the columns and cap beams, and deck with 21,000 cubic yards of cast-in-place deck and bridge barrier concrete. The main towers incline outward and taper and are more efficient than vertical towers. Structural steel was painted to match the concrete color. The design life is 150 years, with portions utilizing stainless steel reinforcement, while other areas use tri-blend cements, lowering permeability. Thermal control plans and curing protocols allowed low shrinkage mixes to assist in control of cracks.
The existing bridge was effectively obsolete from a user's perspective. So it needed to be replaced to alleviate a lot of that congestion, particularly the commercial congestion, and it really does open up the region, particularly that flow of commercial goods from New Jersey to New York.
This team and this particular project essentially started in 2002. That's when we started building the team.
There's a tremendous amount of teamwork and getting all the disciplines and the contractors and everybody together that can actually deliver a project of this complexity and to also be able to finance it.
It's a triple-P project, private-public partnership.
We came up with the idea of a P3, which takes private financing and allows the Port Authority to defer some of the cash flow.
NY&J Link being the equity investor in the project, we have a 35-year operations and maintenance contract with the Port Authority, who is our client. So that's why we've been so involved in the quality implementation of all the products and materials on the project.
It contains a design-build contract, so the concept there is that everything is performance-based.
So my involvement on the project was started in August of 13 with specification preparation, mixed design choices, how we were going to do the different blends of cementitious materials to get optimum design for the 150-year service life of the bridge.
For various aspects of the bridge, it's a 100-year life. Certain things like the towers and the foundations for the towers are 200 years.
So we've invested over $1 billion of capital in the project, both debt and equity. We've invested or committed to invest over $106 million of first loss equity into the project. So from a quality perspective, particularly a concrete quality perspective, that's a first loss source of capital, which is why we've been so interested in the quality aspect of all of the concrete materials and the placement of the project.
The owner has a project agreement with the developer. The developer in turn has a design-build contract with a design builder, which is a combination of a joint venture on the contractor side and a designer.
And we did study early on, even having steel girder approach spans, and it was pretty competitive at initial glance or initial look. But when you start looking at the cost of painting and going through 2 or 3 cycles of painting before handback, it really just changed the tide, and the decision was made to use the concrete structures for the approach and really most all of the main span.
The engineer did a good job at keeping compressive strengths down low so that we could focus more on the durability side of things and have a tri-blend cementitious material that works for heat hydration, shrinkage, crack reduction, and all good things for durability.
One thing that we did put in as prescriptive was stainless steel rebar on the main bridge deck.
You know, one of the challenges we had is you might notice it, we're right next to Newark Airport. So the tower heights at 272 feet, though they seem tall, they're reinforced concrete towers from the base to the top, but they're actually quite short for a cable-stayed bridge.
For the large piers that we have, which are considered mass concrete, we have to make sure that we come up with a mix that doesn't generate a lot of heat.
So the main span towers are all got cooling tubes embedded into them to extract the heat out and be able to cycle the forms up. While the approaches, we had time to be able to just let it cook and leave the forms in place and let it cure out on its own, and then strip and move to the next set of columns.
There was precast concrete girders. They were 170 feet long. It was really quite a sight to see how those were transported here.
The number of concrete placements for the bridge totaled almost 1,200 different concrete placements.
On the main span of the bridge, we also put a polyester overlay at 1.25 inches thickness.
It's specifically chosen to protect and preserve the life of this deck.
We had to blend aggregates, different sizes, to reduce the paste volume.
Literally almost 2,000 feet of continuous jointless structure, all pre-stressed concrete elements, a continuous concrete deck, concrete piers that are integral to the foundations. They're single shaft, single column piers. And it really, the structure, it's more of a modern technology in the sense that we're able to calculate all that. The structure breathes from the temperature ranges, from the live loads, from extreme loading events. It really acts as one, almost like a machine from end to end, with the cable stay anchoring the center portion of it.
This bridge is 81,000 cubic yards of cast in place concrete. And with that, we come a lot of skilled craftsmen that needed to build it, both union from New Jersey side and unions from the New York side that then brought the bridge to meet in the middle.
But I get the privilege of getting to meet a lot of these people and the craft labor and some of the skill, some really dedicated people out here to pull this all together and make it come together as such a quality bridge, a true landmark for the region.
The bridge deck itself, the concrete that we used, that was very low shrinkage, it's very hard to find a crack.
It was a learning experience for everybody, but we've ended up with, I think, a world-class bridge.
It's designed for future transit as well. So the cables, the towers, the foundations are all designed for future transit without strengthening.
Believe it or not, this project is on budget. And within the Port Authority's project agreement, we're within the schedule because our long stop date was in 2019 and we're going to be done this year in 2018.
So I'd personally like to thank New Jersey ACI and the Concrete and Aggregate Association
for recognizing this project.
Giving us this grand award, we really appreciate it, and thank you very much.
Congratulations are certainly owed to this year's New Jersey ACI Grand Award-winning project.